We know you want to get straight to the heart of complex topics, fast. And that's exactly what we do here. Today, we're taking a focused look at IBM Cloud Pak for data.
Right. And we're using the C1000-185 certification exam, kind of like our guide.
Exactly. So Cloud Pak for data, think of it as, well, a unified platform.
Yeah, basically. It pulls together all the tools you need for data management, AI, analytics, puts them in one spot, makes life easier.
Okay. So no wading through manuals today. We have a set of practice questions from that exam. And each one, really, it opens a door to understanding a key piece of Cloud Pak for data.
Our mission is to give you those aha moments, the core insights, but, without all the usual legwork.
We'll set up a scenario, pose the question from the exam.
And then break down why the answer works, and importantly, what bigger concept it teaches us about the platform itself. It's about getting the fundamentals.
All right, let's dive in. First scenario, you're setting up IBM Cloud Pak for data on Red Hat OpenShift. You need it to handle varying loads and stay available.
Right, typical requirement.
The question is, which component is most critical to watch and configure for that? Options are A, service mesh, B, horizontal pod autoscaler, or HPA, C, pod disruption budget, PDB, or D, stateful set volume claim templates.
Okay. The key one here is B, the horizontal pod autoscaler, HPA.
HPA, why that one?
Well, its whole job basically is to automatically scale the number of application instances, pods, in Kubernetes terms, up or down.
Based on?
Usually CPU usage or maybe other metrics you define. So if things get busy, HPA adds more pods. If it quiets down, it removes some.
Ah, okay. So it automatically adjusts resources to match the demand, keeping things smooth.
Exactly. It's all about elasticity, and that's absolutely critical for performance and availability. You configure it right, set the right thresholds.
And it just handles the spikes.
Yeah. It keeps things responsive, but also, helps manage costs by not over-provisioning resources constantly. The core idea here is Kubernetes auto-scaling. That's the underpinning knowledge.
Makes perfect sense.
Okay.
Question 2 moves to access control, security.
Always important.
Scenario. You're setting up security in Cloud Pak for data. The question, what's the best way to ensure different user groups only access resources relevant to their jobs?
All right, options.
A, implement RBAC role-based access control with fine-grained permissions. B, give everyone admin rights. C, create custom Kubernetes namespaces for each user. Or D, use OpenShift firewall rules.
Okay, well, B is definitely out. Giving everyone admin is not good.
No, definitely not.
The best practice here, and the answer, is A, implementing RBAC with fine-grained permissions.
RBAC, so role-based, you assign permissions based on someone's job role.
Precisely. Think of it like job descriptions. A data scientist needs access to certain tools and data. An administrator needs different access. RBAC lets you define those roles and attach very specific permissions.
So you're not giving out master keys, just the keys needed for specific rooms, let's say.
Exactly that. It drastically reduces the risk of someone accessing something they shouldn't, accidentally or otherwise. It boosts security, simplifies management. It's fundamental. The key concept is access control using RBAC.
Got it. Okay, next let's think about data location. Data locality laws.
Compliance. Increasingly critical.
Right. So you're deploying Cloud Pak for data, and you must ensure data stays within a specific country, say, due to regulations. The question asks which feature to leverage.
And the choices.
A, OpenShift compliance operator. B, multi-zone availability configuration. C, data governance policies in Watson Knowledge Catalog. Or D, asset tagging with geographical labels.
Interesting options. But the most direct answer here is C, data governance policies in Watson Knowledge Catalog, or WKC.
Watson Knowledge Catalog. Why WKC specifically?
Because WKC is designed for exactly this, defining and enforcing rules about data. It lets you create policies that can, for example, restrict data movement across geographical boundaries or control access based on location.
So it's not just about knowing where data is, like tagging might imply, but actively controlling it based on rules.
Precisely. You enforce the rules. This is absolutely essential for meeting legal requirements like GDPR or CCPA, avoiding fines, and, frankly, maintaining trust. The core concept is data governance and locality compliance.
Okay, moving into machine learning now. Question 4. You're an IBM Watson studio, part of Cloud Pak for data, developing an ML model. You need to track how different versions perform over time, see its history.
Right. Model lineage and versioning. Very important.
So which feature helps with that? Options. A, data refinery. B, Jupyter Notebooks version control. C, model inventory and deployment spaces. Or D, ML scoring monitor.
The answer here is C, model inventory and deployment spaces. These are tools built specifically for managing the AI model lifecycle within Watson Studio.
Model inventory and deployment spaces. How do they work together?
Well, think of the model inventory as your central library, your catalog of all models. Deployment spaces are where you manage the actual deployment and, crucially, track the different versions, the experiments, the lineage of how a model got to what it is.
So you can look back and see, okay, version 2 performed like this, version 3 like that.
Exactly. You can trace its evolution, compare performance, see what changed. It's vital for debugging, for audits, for collaboration, really understanding your model's journey. The underlying point is model versioning and lifecycle management.
Right. Okay, let's switch gears to troubleshooting. Something's gone wrong.
Happens all the time.
A user keeps seeing installation failures for a service in Cloud Pak for data. The errors point to storage provisioning problems. What's the first most sensible troubleshooting step?
What are the options?
A. Verify persistent volume claim PVC bindings and the underlying storage class configuration. B. Delete and recreate the Kubernetes namespace. C. Restart the Cloud Pak for data operator. D. Redeploy the entire OpenShift cluster.
Okay, B, C, and especially D are pretty drastic first steps.
Yeah, it feels like hitting it with a hammer first.
Exactly. The most logical and efficient starting point is A. Verify the PVC bindings and the storage class config.
Key VCs and storage classes. Remind us quickly.
So a PDC, persistent volume claim, is basically the application saying, I need storage with these characteristics. The storage class defines the type of storage available, like fast SSD or slower block storage. The binding is Kubernetes connecting that request to actual available storage of the right type.
So if that connection or the request or the available storage definition is wrong, things fail.
Precisely. That's often where storage provisioning errors originate. Checking those configurations directly addresses the most likely root cause before you start tearing things down. It's about understanding Kubernetes persistent storage and PVCs.
Good practical advice. Okay, next question zooms in on AI ethics and governance.
This is a very hot topic.
The question is about the watsonx Governance service. What's one of its key functions for deployed AI models in Cloud Pak for data?
Let's hear the choices.
A. Automatically trains models using auto AI pipelines. B. Enables transparency, fairness, and compliance monitoring for AI models. C. Manages Kubernetes resources during model deployment. D. Provides real-time logging for infrastructure health.
Okay, the core function, the main purpose of watsonx Governance is B. It's about enabling transparency, fairness, and compliance monitoring.
So it helps you look inside the black box a bit and check if it's being, well, fair.
Exactly. It provides tools to monitor deployed models for things like bias, does it perform differently for different groups? It helps with explainability, why did the model make that prediction? And it tracks metrics relevant to compliance requirements.
So it's not just about accuracy, but also responsibility and trust.
Absolutely. In today's AI landscape, that's crucial. You need mechanisms to ensure your AI is used ethically and meets regulations. That's AI governance and ethical AI monitoring.
Okay, question 7. Securing connections. You need to connect Cloud Pak for data to an external database. What's a security best practice?
Uh-oh, I sense some bad options coming.
Possibly. A. Store credentials as plain text in the notebook. B. Use default system user accounts. C. Use IBM Key Protect or a vault for secrets management. D. Open public ports for direct database access.
Right. A, B, and D are all major security no-nos.
Storing passwords in code, using defaults, opening ports. Sounds bad.
Terribly bad. The correct answer and the best practice is C. Use a dedicated secrets management tool like IBM Key Protect or HashiCorp Vault.
Why is that so important?
Because these tools are designed specifically to securely store and manage sensitive information like API keys, passwords, certificates. They keep credentials out of your code, out of config files, provide audit trails, and manage access tightly. It avoids exposing secrets. That's fundamental secrets management for secure integration.
Definitely sounds like the way to go. Okay, question 8 delves into RAG architectures. Retrieval augmented generation.
Ah, yes, combining search with generation.
Right, so within Cloud Pak for data, you're using RAG with a large set of documents. What component really helps improve the performance and speed of retrieving the relevant information?
Okay, option.
A. TF-IDF vectorization. B. Vector database with semantic indexing. C. Basic keyword search engine. D. Regular expression parsing.
The key here for performance in modern RAG is B, a vector database with semantic indexing.
Vector database. How does that help compared to, say, keyword search?
Well, keyword search just looks for exact word matches. Vector databases store data, like document chunks, as numerical representations embeddings that capture semantic meaning. When you search, it looks for vectors that are close in meaning to your query vector, not just identical words.
So it understands the intent better. Like searching for dog breeds might find documents about Labradors, even if they don't say dog breeds.
Exactly. That semantic search, combined with the optimized structure of vector databases for finding nearest neighbors quickly, makes retrieval much faster and much more relevant, especially with huge amounts of text. It's a core part of effective RAG. The concept is vector search in RAG architectures.
Faster and smarter retrieval.
Got it.
All right, second to last question, evaluating prompts.
Important for getting the best out of generative AI.
You're using watsonx Prompt Lab to test different prompt styles for an AI. Which metric is most relevant for judging if the AI's response actually aligns with what the user intended?
What are the choices for metrics?
A. Time taken to generate the response. B. Character account of the output. C. CPU utilization during generation. D. BLEU or Rouget. Scores compared against reference answers.
Okay, A, B, and C measure performance or output characteristics, but not really quality or relevance in the sense of user intent. The best answer here is D, using scores like BLEU or Rouge.
BLEU or Rouge. What do they actually measure?
They're standard metrics in natural language processing. Essentially, they compare the AI-generated text to one or more human-written ideal or reference answers. They look for overlapping words and phrases, n-grams specifically.
So a higher score means the AI's output is linguistically closer to what a human expert considered a good answer for that prompt.
Generally, yes. It's a quantitative way to assess how well the output matches the expected content and structure, giving you a sense of alignment with the prompt's intent. It's about evaluation metrics in natural language generation.
Okay, makes sense. And our final question brings us back to governance.
Full circle.
When you deploy an AI model in Cloud Pak for data, how do you ensure your data governance rules are still being followed during deployment and operation? Which capability do you need to configure?
Options.
A. Auto AI pipeline constraints. B. Decision optimization engine. C. OpenScale drift detection. D. Watson knowledge catalog policies and data classes.
And the answer is D, Watson Knowledge Catalog Policies and Data Classes.
WKC again. So it's not just for data at rest.
No, its role extends throughout the lifecycle. By defining policies like this type of sensitive data cannot be used as input for this model deployment. And classifying your data using data classes, WKC can enforce these rules as the model runs, as data flows through your AI pipelines.
So it acts like a gatekeeper, ensuring the AI workflows respect the data rules you've set up.
Exactly. It integrates governance directly into the operational AI process. It ensures responsible, compliant use of data, which is crucial. The key concept is policy enforcement via Watson Knowledge Catalog.
Wow, okay. How do all these capabilities truly interact in a complex, real-world deployment? What are the synergies you could leverage, but also what are the potential friction points or complexities when you try to implement all of this together?
That's a great question to ponder, because making it all work seamlessly is the real challenge and the real power.
Indeed. Consider that interplay. And, of course, keep exploring these topics further.
There's always more to learn. Thanks for joining us on this deep dive.